in the week 6 folder, go to the atomic structure simulation right here. Come on, load. My document. Click on atomic structure review, and then open this link. After that link is open, go to the guest login and type in your name. Click login. Once you're at this screen right here, let me know in the chat. Type done in the chat. Once you're at this screen, type done in the chat. Yes, use the guest login. All right, looks like we're all there. All right, so I'm going to walk you through some of this. This is important because this is the basis for all the rest of chemistry we're going to talk about. So after this lesson, from here on out, I'm going to assume you know what protons, neutrons, and electrons are, where they go, and what they do. And based on the warm-up you guys showed me, you guys do know that as well. So that's what we're going to be working on today. It's kind of cleaning that up, making sure we're on the same page. So this tutorial is going to focus on the tip of a pencil. Now, the tip of the pencil is everyone calls it lead, but it's not lead. All right, so if you ask for more pencil lead in your mechanical pencil, lead is a common term, but it's actually carbon. It's called graphite, which is a type of carbon. Lead itself is a poisonous metal. So lead is a real thing, but it's not what's in pencils. If it was in pencils, kids everywhere would be poisoned and it'd be not good. So lead is bad. You don't want it in the tip of our pencils. But for some reason, it got started calling that, and maybe at some point in time there was lead in a pencil, which is a terrible idea. But lead is a separate element from carbon. So you're going to go ahead and you're going to click on the tip of this pencil. All right, and we're going to take a look at an atom. All right, so now make sure you understand that this is a simulation. It's meant to enhance your knowledge of atoms. It's not super realistic. For example, you can't see an atom with a magnifying glass. Okay, but what is true is that atoms vibrate like this. So when you do see an atom, you need a super expensive, super large microscope, but we don't have one. So this is like what it would look like though if you did look. The atoms sit there and they vibrate really close together like this. And that's what happens in a solid. So in a solid, the atoms are vibrating back and forth. In liquids and gases, they're bouncing apart, farther apart. But we'll get to that later, after the periodic table. So it's going to zoom in even more. And we're going to focus on one atom. All right, so the electrons fly around a nucleus like this. And if we slow them down enough, we'll be able to look at the electrons. All right, first we're going to start with the nucleus in the center. So the center of the atom is the nucleus that has the protons and the neutrons. So the region of the atom where we can find this is the nucleus. So That's the first question here. So it says protons are found in the what? Nucleus. Type that in. So that's how this works. You go through on this website, you find the answer, you go back, you type it in. So what we're looking for is the number of protons. What does that determine? So we can already see that the blue proton is in the center of the atom, and that's called the nucleus. The number of protons will determine what element an atom will be. So a number of protons determines what element the atom will be. So in this example, like I said, we're zooming in on the tip of a pencil. The tip of the pencil is made of carbon, so you'll expect to find a carbon atom there. So the number of protons determines what element atom will be. So that's the most important part that the protons play, is that they determine what the atom will be. So in a carbon atom, there are 6 protons. We also call the number of protons the atomic number. So we organize these atoms and elements by their atomic number on the periodic table, which is what we're gonna get to later this week. So the number of protons is called the atomic number. So those should go hand in hand with each other. So if I say the atomic number, you should think protons. If I say how many protons does an atom have, you should think of the atomic number. Now, if you look at this periodic table here, all right, we're going to see one like this later this week. So carbon right here is the one we're looking at. You can see up here, there's a number 6. That is the atomic number. And that's true for every atom on this table. All right, whether you got potassium, boom, atomic number. All right, what's another one you might have heard of? Silicon, boom. Aluminum, boom, atomic number. Chlorine, like in bleach, atomic number 17. Iron, like the metal, atomic number 26. Gold, atomic number 79. So all that means is that there's 79 protons in the gold atom. Same with silver and copper. That's all this number means. Every number on this cube means something. We'll learn about what those mean later, but everything on this means something. Oxygen is one you're familiar with. It has 8 protons. And if you look, that this periodic table is organized by number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The crazy thing is if you just add one little proton to oxygen, the thing that you breathe in and you are required to have in order to live, you make fluorine. If you breathe in fluorine, you'll die. Fluorine is very poisonous. It's the most reactive element on the periodic table. It is crazy stuff. They won't let me touch it. They don't sell it to teachers because it's that dangerous. So fluorine is bad news. And the only difference is 1 proton. That's crazy. 1 little proton, something you can't even see, makes this much of a difference. So the atomic number is the whole number found in the symbol of the element. So where can you find the number of protons? Above the symbol of the element. So on a periodic table, and everyone, if I ask you, what is the atomic number of, let's pick a weird one, Californium, you should tell me 98. The protons have a mass of about 1 AMU. An AMU stands for atomic mass unit. Basically what this slide is saying is that all you need to know is that the proton is heavy, and it makes up most of the weight in an atom. We're not going to really talk about how much an AMU is because for this class it doesn't play a big role, but it is important in like more complicated chemistry, but we're just not going to talk about it now. So all you really need to know is that it is one of the heavier pieces of an atom. All right, protons have a +1 charge. +1. Protons have a +1 charge. They are protons P positive. Protons P positive, positively charged protons. And remember, like I said, they wouldn't stick together in an atom if it wasn't for the neutrons, which we're going to look at next. If you take two positive ends of a magnet and stick them together, they repel. Atoms work the same way. So if you take two positive protons and you try to stick them next to each other, they're going to repel. They're going to shoot away from each other. And that's not good if you want the atoms to stick together, because you need the atom to stick together. And if an atom falls apart, bad news. So that should take you up from 1 through 5. You should have 1 through 5 filled in. Okay, does anyone need me to go over any one of those? Number 2, the protons determine what the element will be. That is on slide 8. So on slide 8 determines the number of the protons will be. All right, so let's move on. Next is the neutrons. They're the other particle that is in the nucleus. So the neutrons are in the nucleus. Neutrons are found in the nucleus, number 6. Neutrons are found in the nucleus. Neutrons do not have a charge. Okay, so that's important. If you look at it, you can think about nucleus, neutrons, neutral. Neutrons, no charge. Through forces and attractions, they are able, other than attractions, so like the positive negative thing is the attractions. There's other forces that hold together an atom, and that's how the neutrons function. So we're not going to get into those because there are several other forces in an atom, but again, that's more complex chemistry. But for us, all you need to know is that they help hold the nucleus together by spacing the protons apart. Remember, the protons want to repel each other. They don't want to be by each other. So the neutrons space them far enough apart that repulsion between two positive atoms or protons doesn't happen. So the neutrons act like spacers. So the neutrons have what charge? This would be 0. And the neutrons help protons by keeping the nucleus together. All right, so neutrons have basically the same mass as a proton. So they are another contributor to the mass of an atom. So the mass of the atom is made up of the protons and the neutrons. That's an important thing to remember. So the mass of the protons and the neutrons are the same. Mass of the protons and the neutrons are the same. All right, Aaron, that's a great question. She asked, do electrons and neutrons mix since neutrons don't have a charge? No, they normally don't. They don't mix because there's just not an attraction between the two. So the protons are attracted to the electrons because they're opposite charges, like a magnet works. But since the neutrons don't have a charge, they basically just get ignored by the electrons. So it's not that they don't like have a reason to mix, they just don't, they're not interested in each other. A great question. All right, so the last type is electrons. They're the smallest, and they don't add anything to the mass because they're that small. The only thing I need to point out is that an atom is mostly made up of empty space, which is really weird to think about because there's so many atoms that are packed so close together that they can make solid objects. So you would think that they would have to be close together, but if you're looking at an individual atom, it's mostly empty space. So for example, think about Withrow. So think about like where my class would normally be in Withrow in that room. If you think about it, if that was the nucleus, if the center of the atom was my room at Withrow, the nearest electron would be out by I-71. So it'd be all the way out by the highway. So the electrons float around the atom, but they stay pretty far away from the nucleus. So think about it like the sun, or the Earth orbiting around the sun. If the Earth orbited around the sun in a crazy random pattern, but stayed that far away. Electrons orbit around a nucleus, but they don't stay on a set path like the sun does. But you can see that most of the electrons would be far away, like the Earth is far away from the sun. Electrons have a -1 charge. So we've covered the mass. The electron's mass is so small it doesn't matter. Electrons have a negative charge. Okay. So in this atom, this one's considered neutral because the protons are equal to the electrons. And if you think about it, that makes sense because the protons have a positive charge. The electrons have a negative charge. If they're out of balance, then the atom will have a charge. And that charge will be important later when we talk about bonding because you'll see that that positive negative attraction will cause atoms to come together. But in a neutral atom alone by itself, you'll see that as long as they're equal, you'll have a neutral atom. So remember this. Okay, so if I'm building carbon, 1, 2, 3, 4, 5, 6. Oop, I missed one. All right, I'm not going to worry about the neutrons in this one since I want to make a point about the charge. So normally I would have had neutrons. All right, but in order to make this neutral, I would have to have an equal number of electrons. So once I have an equal number of protons and electrons, you can see up here the atom is neutral because there are equal number of positive and equal number of negative charges. So like I said, this is a simplified version. This is what the atom would actually look like. With a dense inner ring and the atoms floating around outside of it. So we're going to focus on electrons moving forward more than we will protons and neutrons because the electrons are responsible for all the behaviors of the atoms. So the protons identify the atom, so it would give you an atom of carbon, but the carbon's behavior, how it reacts and bonds with other things, is all the electrons. So we're actually going to spend a lot of time talking about these electrons. So the electrons are responsible for the properties of individual atoms. And properties is a chemical term, is a term that's in chemistry that's basically just means the characteristics. Like someone's characteristics could be they're tall, they have good style, they're hyper, they're quiet. You know, those things are the same if you think about people as to atoms because atoms have qualities like that too, and it's based on the electrons. So the electrons are responsible for the properties of an atom. All right, and that should take us through the end of the notes. All right, so for this next part here, this table, all right, you're going to use this drag and drop activity in order to fill it in. So you can see that we're talking about the proton, So what is the charge of a proton? Look at your notes. What's the charge of the proton? Put it in the chat. Positive, good. So I'm going to choose this positive one. Drag and drop it. If you're right, it'll stick. If you're wrong, it won't. So if I take the one, I can't take this out. But if I were to try to put the negative one in there, it would fly away. It won't stick. The mass of an atom or a proton, remember we talked about it's only where you should only think about heavy. All right, don't worry about the 1 AU. It's a heavy part. So the location of the proton, where is it located? Which one of these words fits it? Where is it located? Where is the proton located? Good, Katie. In the nucleus. So if I try to do something else, like say I try to put outside the nucleus in there, like I said, it won't stick. It'll fly away. See, if I try to put anything else besides the right answer, it won't stick. So if the right answer will stay, and the proton determines the identity of the atom. So only the right answer will stay. If the answer flies away, you got it wrong, try something else. Then you're going to use this information to fill out your table. So the proton, the charge was +1. Mass is heavy. Location was in the nucleus. And the importance is it identifies the atom. So that's how you fill in this table. When you get them all right, you can go to the next one and try it for the neutron. And remember, whatever you drag and drop, it has to be the right one in the right box. Once you get them all right, put them in the table. Okay. So I'll give you guys get about 5 more minutes in class to finish this up. If you have any questions, put them in the chat. If you need me to go over any of the boxes or the blanks, let me know.